Hey guys, in this video we're going to take a look at using the 4 different triangle congruence theorems that we've been using in proofs. And if you remember, those 4 are side, 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 angle, side, where the angle has to be included between the two sides, angle, side, angle, and angle, angle, side. Again, with this side having to be included between those two angles. Okay, so if we look at the first one they give us, they want us to complete the proof so that triangle STX is going to be congruent to triangle VUW. So if we start working through the proof that they give us UV is congruent to ST, and that's given in the picture. So UV to ST. And then they give us WX is congruent to TU. And if you notice, that's not the whole entire side. And then SX is congruent to VW. And that's listed as our 3 givens. So this first one is definitely one side of the triangles we're working with. WX and TU are not. They are only a portion of the side. They're not a whole entire side, so we can't label them as a whole entire side. And that's going to be the big thing between this lesson and the last couple that we've done. In this lesson, you've got to really focus on, is this the whole entire side or the whole entire angle that I need to make the 2 triangles be congruent, or is it just a part of it? And this one here, that's an example of where it's just a part of it. So then we can't label this as one of our sides. Looking at the next one, we've got SX and VW. So that is another side. So if we're looking at the 4 options that we have when we do these, we've got side, 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 angle, side, angle, side, angle, and angle, angle, side. Looking at the fact that we have 2 sides for our triangle, we're probably going to use side, 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 or side, angle, side. Just depends on what we're given to work with. I guess it could still be possible for angle, side, angle, or angle, angle, side to be what we use to prove the 2 triangles are congruent, but probably not. Most of the time, whenever you get to a point where you have 2 out of the 3 different things that you need to show that they are congruent, you're going to end up using one of those 2. Okay, so if we keep going, so here they notice that they didn't have the whole entire side of that triangle. So they say, well, if you wanted to do the whole entire side, that whole entire side would be made up of WX plus TW. And so they're doing this part right here plus that part right there equals the whole entire part. And for this one, they do additive property of length. I've always seen it referred to as segment addition property or postulate. Segment addition postulate is what we've always done, but they refer to it as the additive property of length. Those 2 are the same exact thing. Okay, so they do this part here plus that part will equal that whole entire side. So that gives us the whole entire side for this triangle. We still need that whole entire side for the other triangle. So that's what they say right here. This whole entire side, or UW, is going to be equal to the 2 parts that make it up. So here we've got part plus part is equal to the total thing. So again, we're doing the additive property of length. Or the segment addition postulate. Okay, so now we've got these 2. We know this value in this triangle and that value in that triangle. In order for the 2 triangles to be congruent, since we're working with sides here, we would have to have a statement that says all 3 sides are congruent to each other. And we already have this here with UV is congruent to ST, and then SX is congruent to VW. Now we need this right here. We need those 2 to be congruent. So if you look, they'd say, well, we would like for tx, the whole big one, so this green one, we want tx to be equal to uw. And in order for those two to be equal to each other, these two would have to have the same exact thing right here. And it almost is the same. We've got TW there and TW there. What's not the same is the WX and the TU. So we want to replace one of those two with the other so that these two can be equal. And if you look, that statement right there says WX is equal to TU. So we can take this WX here, replace it with a TU, and that'll give us this statement right here of TX. So they're using this statement right here is going to be equal to TU plus TW. So it's instead of WX, they wrote a TU because they were equal. So it's instead of this, they write a that. That's going to be substitution. Okay. And so now that we have the same exact thing here, TU plus TW and TU plus TW, we can say, so because they have same thing there and same thing there, we can say that these two are going to be equal to each other. And so instead of writing TU plus TW, they wrote TX because they're equal to the same value. And so instead of this, you write that. It's going to be the substitution property. And so there, that shows that this side right here is congruent to that side right there. And once you have all three sides shown as congruent, this was our third side right there, you can say the two triangles are congruent based on side, side, side congruency. Looking at the next one, they tell us that, and with this one, see this one, it was really nice because they marked everything in the picture with us. This one they didn't. So whenever you go through and double check and write down and list your givens, you're gonna wanna be sure to label it in the picture as well. So you've got URV is congruent to SRT. So URV is congruent to angle SRT. So that's those two right there. There's that one right there. So that means this one is given. Okay. Look at next, they tell us angle RTV is congruent to angle RUS. And side, oops, it's right here. That's given. And then RU is congruent to RT. RU is congruent to RT. And that's a given. And they want us to show that RTV is going to be congruent to triangle RUS. So this angle right there is what we would need. So there's a side. We've got a side for each of them. There's a side, there's an angle. So if we think of that list of 4 that we have for congruency, we've got side, 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 angle, side, angle, and angle, angle, side. So we've got a side and an angle. So it's probably not going to be side, 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 but that leaves all the other 3. So, we've got an angle, we've got a side. Here they give us an angle, but it's not the whole entire thing. Well, if it were the whole entire thing, we'd be looking that whole angle for this, for the black triangle that I outlined, and then this whole thing for the blue triangle that I outlined. And if you notice, the angle that they have to include is going to be the same exact angle. So we're probably going to go, this would be an angle, that would be a side, and that's going to be an angle. So that's going to be probably angle, side, angle is what we're looking for. All right, so in order to get that angle, we would have to include this angle in with the whole big thing, and that's where they start right here. They tell us that the whole big angle, TRV, so TRV, that whole angle right there, is going to be equal to, and I should have done 2 arc marks. There. So that angle right there is going to be equal to TRU plus URV. And we know that, well, if you look, we've got this angle right here plus that angle right there gives us the total angle we see there. And so it's another part plus part is equal to total. But this time we're talking about it instead of the additive property of length that we had right here, we're now working with angles. So this is going to be the additive property of angle measure. And I call it the angle addition postulate. Okay, so that gives us that angle right there. And then it says angle SRU, so that whole big angle is going to be equal to SRT plus the measure of angle TRU. So that's another part plus part is equal to total. So that's another additive property of angle measure. Well, if we're going to do this and prove these two triangles are congruent using that angle side angle we're going for, it'd be really nice if this angle right here would be congruent to this angle right there. So in order to do that, we would have to have SRU is equal to TRV. And if we look in here, we've got a TRU here and a TRU there, but those two are not the same. So instead of a URV, we would like to write a SRT. So if you look, instead of that, we would like to write that there. So we've got to find a spot in the proof where it says URV is equal to SRT. So URV is equal to SRT is right there. So then we're going to take this statement and rewrite it down there and say TRV is equal to TRU plus SRT. So now that they have said that, so it's a case of instead of this they wrote that, that's substitution. So now we're looking for, we've got these two statements are now the same. So there's the measurement of angle SRT and SRT there and TRU there, TRU there. So because these two statements are exactly the same, we can say that this angle right here is equal to that angle right there because those two are exactly the same. So we take those two and we can set them equal to each other. So a way to look at it is measure of angle of SRU is going to be equal to that plus that. Well, that plus that is also equal to the measure of angle TRV. So instead of measure of angle SRT plus measure of angle TRU, it's going to be equal to TRV, so substitution. So there's our angle there, there's our side, there's our angle for that first triangle. And then if we look here, the blue triangle, that angle there and that side there with that angle there will give us angle side angle congruency. Alrighty, looking at the next one, they tell us that side side FG is going to be congruent to IJ. And we know that because it's given. And then they tell us that GH, so that part right there, is congruent to JK, so that part right there. That is another given. And then HI is congruent to FK. And we know that because it's given right there. Okay. And they want us to show that those two triangles are congruent. So if you look, we've got those two sides are congruent to each other, and those two sides are congruent to each other. And these two are almost congruent to each other, but not quite because they're missing that little JG in the middle. But if we were going to have that side right there, it would be called GK. And GK is made up of JK plus GJ. So it's this part plus that part is equal to the whole total thing, and that is the additive property of length. So if we're going to do it to get this side of the triangle going there, we need to do it to get the other side of the triangle going here. So, and that's what they do. They do HJ is going to be equal to GH plus GJ, and that's another additive property of length. And just a reminder, this is just another way to say segment addition postulate. Okay, well, if we're going to show that these two triangles are congruent, you've got to be thinking again, our options are side, 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 angle, side, angle, side, angle, and angle, angle, side. And this is going to be side, side, side congruency because we've got that side there, and we're going for this side there. So if we're going to do that, we need to be able to show that GH is equal to KG. And they do that, sorry, JH and KG, they just name them backwards. So we need those two to be equal to each other. And if we look up here, here's a GK, and there's a HJ. And in order for these two to be equal to each other, these two statements here have to be equal to each other. So if we look, the GJs are the same, but the JH and the GH are not the same. So down here in the next step, they have GK is equal to, and instead of JK, they replaced it with a GH. And the way they're able to do that is because of that statement right there. It says those two are equal. So GK is going to be equal to GH plus GJ, and that's by the substitution property. It's instead of this, they wrote that. So now that these two here are exactly the same, GH plus GJ, the two things that they're equal to can be set equal to each other as well. So again, instead of GH plus GJ, we're going to replace it with GK. So substitution again. So with that, we were able to show that all three sides are congruent to each other. So it's going to be side, side, side congruency. Alrighty, looking at the next example, they can have you start filling in statements. So looking at this one, we want to complete the proof to show that triangle RSU so we're looking at that triangle right there is going to be congruent to triangle RVT. So we want to show those two triangles are congruent. And if we remember a list of 4 theorems that we have to show triangles are congruent, we've got side, 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 angle, side, angle, side, angle, and angle, angle, side. And so if we look at the marks that we have on the triangles, for the black one we've got this angle here and a side there, and then for the red one we've got an angle there and a side there. And this is an angle mark here, but it's not for that whole entire angle, so it's not going to be, this angle is not going to be enough. But if you notice, this is just about the same. It is the same angle. So if we add that angle to the angle that we're given, and this angle to that angle that we're given, that would give us another angle. So we could have angle, angle, side. So if you don't see the angle, angle, side, that's fine. Hopefully you at least notice that there's angle stuff going on, so that it's probably not going to be side, 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 but going to be one of those 3 right there. So if we start working through what they've given us RU is congruent to RT. So RU is congruent to RT. It's marked for us in the picture. So, and they also give us angle SRT is congruent to angle URV. So we've got those right there, and that's another given that's shown in the picture for us. Looking at the next one, oh, did I mark the wrong ones? I sure did. SRT, so I'm just gonna mark it in yellow. I'll make this one be yellow. So SRT, that angle right there, is going to be congruent to URV, that angle right there. And then there's our angle S and angle V. And then they go next for the measure of angle TRV. So this angle right here is going to be made up of that angle plus that angle, and that'll be our additive property of angle measure. And then looking at SRU, because they're trying to get this angle in with those. So SRU is going to be equal to SRT plus the measure of angle TRU. And they're trying to make those two to be equal to each other. So they want to replace the URV with the SRT. And that's exactly what they did there. So now you've got TRU and SRT. So the same thing written here as you have there. So that tells us that these two are equal, sides are equal to each other. And so here is RU and RT, here's one of our sides. And then angle SRT and URT is not one of our angles because it doesn't cover the whole angle of the triangle. And angle S and angle V is one of the angles, so here's one of our angles there. And then those two angles are equal, so there's a second angle there. So here's we have a side and 2 angles, so that rules out side angle side for us. So now it matters as to whether we've got an included angle, or sorry, an included side or a side that's not included. So we've got to really look at the picture to see what we have going on here. So if we look, here's a side, we're looking at the red triangle, here's a side, here's an angle, and there's another angle. So this is one of our angles in that triangle, and that's the second angle in that triangle. And if it was going to be an included side, it would have to be side RV, and it's not, so it's looking like it's going to be angle, angle, side. We need to check our other triangle to make sure though. So if we look, and we go over here, we're looking at this angle right here. So there's one angle right there, and then I'm labeling it backwards. So there's one angle right there. This one matches up with that one right there. And then here's a second angle right there, those two matching up together. And if this were going to be an included side, it would have to be RS. And the one that we have information for is not RS, it's RU. So at the side is not included between those two, so it's going to be angle, angle, side. And because we were able to figure out for sure which triangles are going to be congruent, that makes this, and we've shown that we have one side congruent and two sets of congruent angles. That gives us enough information to say that our two triangles are going to be congruent to each other. So triangle RSU is going to be congruent to triangle RVT by angle side congruency. So I forgot to number these back here for these two, and I'll go back through here and do that. I'll start with this one here first. So if we look, we've got FG here and JI there, and that makes one set of congruent sides for the pair of triangles. And then we're looking at GH to JK. That is not a set of congruent sides, that's a portion of it, so that cannot be used as one of our congruent sides. So then looking at HI to FK, that's another set of sides that are congruent there. And then down here at the bottom where they've got HJ is congruent to GK. Yep, HJ is congruent to GK. That gives us our third side for congruency, and that's how we ended up with the side congruency there. Okay, and looking at this one, we've got URV, and that's just a little baby portion of it. That's not the whole thing, so this is not one of our angles that we're using to help prove those two triangles are congruent. But RTU, or RTV, that is one of our angles there, and it matches up with that angle there. So that's one of our angles pairs, and then RU is congruent to RT. Both of those are sides. So this was one angle, and this was one side. So there's one of our sides. And then looking at the last one, we have SRU. There's our second angle. And then TRV, there's our second angle there. So second angle there. And then the order really mattered. So it went angle here to a side there to an angle there, and double checking in the other triangle, angle there to a side there to an angle here. So that's what made that be side angle side for that one. Alrighty, looking at the last proof that we have to do. Remember, these are ones where we can have fill in the blanks for both statements and reasons. We just need to take a look at what we have and where we need to go. And this one's kind of a little bit different than what the other ones did. Hopefully you've noticed that these two were very similar and that they were having you work with sides and doing side, side, side. And while this one is angle, angle, side, and this one is angle, side, angle, they are very similar to how they're done and kind of the line of thought that they have you guys doing. And this one is using transitive property, but it will also take substitution for this one. Every time I did these problems, it was taking substitution for them. So this one, so whenever you get problems like this, you can kind of follow this line of thought that they have if you're kind of having trouble with them. But they will every once in a while throw in one just to check and make sure you know all of your definitions. And this was one, and it was the best one that I could find where they did something like this, so that's why I'm showing it to you. You just got to look at what you have, use what you know, and go from there. So we're looking triangle FGJ. So FGJ is equilateral. So there's where that's shown in the picture there. And then HIJ is also equilateral. So already with those two statements, I'm thinking in my head that we're looking at side, 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 angle, side, angle, side, angle, and angle, angle, sides are the four options that we could have to be working with these. So with them giving two equilateral triangles, I'm already thinking we're going to be doing something with sides. Just because, well, equilateral means equal sides, so I'm looking for something to do with that. And the way to know for sure is to look at the triangles they have that they want to prove are congruent. So triangle FIJ. So we're going for this triangle right here. They want it to be congruent to GHJ. Okay. So I'm looking at what those two triangles share in common. So if I look, these two triangles here both share this side right here. I know that's not the same side, but they both share a side to this equilateral triangle. And if you look over here, these two both also share a side to this equilateral triangle. So I'm thinking at least two sides, which rules out those two right there. Okay. So I'm going to go with that. I'm like, well, those two sides look like they're congruent. Well, they are because it's equilateral, and these two are going to be congruent because they're equilateral there. So I'm going to go ahead and list it. So GJ is going to be congruent to GJFJ. And how do we know those two are congruent? We know those two are congruent because they're sides of the equilateral triangle, and that's just what it means. It means that those sides are going to be congruent and the same, that we're using that definition of equilateral triangle. So if we're looking, those are two congruent sides. So that's one set of sides for saying that those two triangles are congruent. So now to do the next ones, we did GJ, so HJ, and this will be step 4, is going to be congruent to HJ, IJ. And it's the same exact reasoning here. We know those two are congruent because of definition of equilateral triangle. Okay, and if we go and mark those in our picture, we've got GJ is congruent to FJ, and then we've got HJ to IJ. So I'm going to put 2 tick marks there. So in order to do side, 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 we would have to find some way to say that GH is congruent to FI. And if we look at the information they give us, they don't give us anything to be able to say that. So then it probably can't be side, side, side. So we've got to go and try side, angle, side. So we've got to find a way for the angle that is included between those two sides to be congruent to each other. So if we're looking, the included angle is going to be this angle right here between those two. Ooh, and if we look, those two angles intersect and are created by 2 lines. And the lines that, or the angles that are opposite, are going to be congruent. So for our next step, we can say angle GJH is going to be congruent to angle FJI. Well, why are those two going to be congruent? They are vertical angles. And I think in this, these practice problems, it's called vertical angle theorem. I would use definition of vertical angles, but this is something else that could be used. So if I take a tally of what we have going on here, we've got GJ is congruent to FJ, so that gives us one side. We've got HJ is congruent to IJ, which gives us a second side, and we've got angle GJH and angle FJI for one angle. And if we look, that angle's between those two sides, so there's our side angle side. So we're able to say, and I'm going to write it in the same order they have up here, triangle FIJ is going to be congruent to triangle GHJ. And we know this because of side, angle, side congruency. So there's a couple different proofs of where you have to fill in some statements and reasons, and then we did several proofs where all we had to do was the reasons, and some did with sides and some that worked with angles. If you have any questions, be sure to write them down and ask me when you get to class.